Bless your heart. Some kind of way you done found yourself for the online tutoring of Mr. Whittington's. Is it Mr. or Mr.? Mr. Whit? How that man say that? Anyway, today's episode is on factories. Now, I don't know what in the Sam here any of this means, but I hope you enjoy yourself, so get your ink pen and your pencil and get ready to learn about factories.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about factoring perfect square trinomials. Alright, so what we have here are the forms that you may find your expressions in. So anytime you're dealing with perfect square trinomials, you may have the form of it look like either of these situations right here, and that is you may have a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Now, what does that mean to you? Bottom line is that your first and your last terms are going to be perfect squares. Alright, and when I mean perfect squares, I'm talking about 1 squared, 2 squared, 3 squared. So we're talking about numbers like 1, 4, 9, 16, 25, on and on and on. That's right, those perfect squares. And when it comes to perfect squares, ladies and gentlemen, I'm going to remind you guys again, you must memorize your perfect squares. That's right. As a math student, to be successful, recognition is key when it comes to perfect squares. So I recommend that you learn your perfect squares from 1 squared, which is 1, all the way up to 15 squared, which is 225. But if you want to be an A+ student, yeah, and I know you do, go ahead and learn your perfect squares all the way up to 25 squared, which is 625, by the way. Alright, so these are the two forms that we're going to look at, and notice in the boxes here I have the actual factoring patterns. The factored form is going to look like what you see in the boxes here. Alright, well, let's go ahead and look at some examples after I remind you about the perfect squares. So here we go. Here are your perfect squares, and here is what I'm talking about. Alright, knowing those perfect squares from 1 squared all the way up to 15 squared. This will help you recognize when you have a perfect square trinomial or when you may potentially have one. So know your perfect squares from 1 squared to 15 squared, and the numbers that you see in red are your perfect squares. These are the values that you want to be able to recognize right here. Alright, that's what I'm talking about. And so I have the list from 1 to 15, but if you want to be a superstar in math, a superstar, go ahead and memorize those all the way up to 25 squared. Alright, let's check out number 1. Now, some textbooks and some teachers will have you verify whether or not this is a perfect square trinomial before you start factoring it. But I say don't do that. No. Let's go ahead and assume that it is a perfect square trinomial if, and only if, the first term and the last term is a perfect square. The reason for this is that most of the time you'll find these problems in sections of textbooks, or it will be part of the curriculum of your class where you're going over perfect square trinomials. So the likelihood that you're dealing with a perfect square trinomial is almost, every time. So let's not get bogged down in verifying whether or not it's going to be a perfect square trinomial first, but don't fret, teachers, and don't fret, students. We will still verify that it's a perfect square trinomial before it's all over with. Alright, so check out my flow. The first thing I'm noticing in problem number 1 is that y squared is a perfect square. That's right, because y times y is y squared. I also know that my last term, 36, is also a perfect square. So this is going to be that second form of a perfect square trinomial that you saw on that first screen I showed you. So what I'm going to do here is I'm going to open up 2 sets of parentheses, alright? And then what I'll do from there is I'll take the square root of the first term, which is y, because y times y is y squared, and then I'll take the square root of 36, which is 6, alright, because 6 times 6 is 36. And then the sign of the middle term must be the sign of both of your values here. So because my middle term sign is a negative, then that means that the 6 in both sets of parentheses must be negative. Okay, so this leads to my potential answer. However, it's at this step that I'm going to verify whether or not this is going to work out fine for me. So what I'll do is the following. I'm going to check the outer product here. So if I were to multiply y times negative 6, I would end up with negative 6y, right? Okay. And if I were to multiply the inner terms here, this negative 6 times y, I would also end up with negative 6y. So what you want to do from here is you want to combine these terms to see if it equals to your middle term. Well, negative 6y and negative 6y do combine to give me negative 12y, which verifies that this is correct, and that means that I can simplify this to my final result, which is going to be the following. It'll be the quantity of y minus 6 squared. That's right. You must combine these two like binomials into one simplified form because otherwise it would not be simplified. Remember, just like with fractions, you're always responsible for simplifying your results. So for you to give your teacher or submit an answer of y minus 6 times y minus 6, though it's mathematically correct, it's not simplified. So the preferred answer is going to be the quantity of y minus 6 squared. That's right. Now let's go ahead and put a red box around this. All right, got my red box. All right. And that does it for problem number 1, just like that. So the result of y squared minus 12y plus 36 is the quantity of y minus 6 squared. That's it. All right, let's look at problem number 2 now. In problem number 2, we have the following problem. We have 4x squared plus 12x plus 9. So I'm already thinking that this is going to be a perfect square trinomial because my first term here is 4x squared, which is a perfect square. It's the result of 2x times 2x. All right. Then as I look at my last term, that positive 9, yeah, that's also a perfect square. Why is that? Because 3 times 3 is 9, right? Okay, so I'm going to go ahead and assume that the overall trinomial is a perfect square trinomial. And this is definitely going to be in the form of the first choice that I showed you earlier on that first screen, that a squared plus 2ab plus b squared form. All right? So that means that I'm going to go ahead and open up 2 sets of parentheses here. And the square root of the first term, that 4x squared, is going to be 2x. That'll be the first term inside of my parentheses. Then the square root of 9 is going to be positive 3. All right, so I got my positive 3 right there as the second term. Because the middle term sign is positive, that means that both 3's need to be positive. And this is where I'll verify whether this product will get me back to the original trinomial. And I'll do that by multiplying the outer terms together as well as the inner terms together and then checking out the sum of those. So here we have 2x times 3, which gives me 6x. And then the inner terms, 3 times 2x, that'll give me 6x as well. So when I combine these two 6x's, do I get 12x? Yes, I do. So that means that's correct. So all I have to do now is combine these binomials to get my result. And so I'll have the quantity of 2x plus 3 squared. And that's it. Red boxing it. Just like that, ladies and gentlemen. That was problem number 2. On to the next one. In problem number 3 here, we have 25x squared minus 70x plus 49. So once again, I'm recognizing that the first term is a perfect square because 25 is a perfect square and obviously x is to an even exponent. And by the way, ladies and gentlemen, anytime you have a variable raised to an even exponent, it's automatically a perfect square. Every time. Okay? So here my first term is 25x squared, a perfect square, and the last term is 49. Yeah. Because 7 times 7 gives you 49. So that's a perfect square. So once again, I'm not going to verify whether or not this middle term is what it should be until I'm in the middle of my process here. So I'm going to go ahead and open up 2 sets of parentheses, like so. I'm going to take the square root of the first term. Well, the square root of 25x squared is 5x. Yep. Then, taking the square root of 49, that gives you what? Bingo, it gives you 7. Absolutely correct. Good job, by the way. And so what we're going to do now is determine what sign each of these 7 should be. Well, remember I said that the sign of the middle term is going to be the sign of both of these values here. All right. So since the middle term in the original trinomial is negative, the 7's both must be negative, like so. All right, so now let's verify whether or not this is correct. If you check the outer terms product with the inner terms product and then combine those results, we should end up with negative 70x. So let's see if that works out. If I multiply 5x times negative 7, that does give me negative 35x. Then multiplying negative 7 times 5x, that gives me a negative 35x. And then if I combine those two, and negative 35x and negative 35x combine to negative 70x and done. So that verifies that this was a perfect square trinomial, which means I can write my result as follows. I can write it as the quantity of 5x minus 7 squared. Just like that. All right. Do you smell a red box coming? I do. And here it is, Just like that. Boxing up my answer, ladies and gentlemen. Done and done. And remember, having the binomial times the binomial in that form is not your final answer. You'll need to simplify it by combining those into one binomial raised to a power. Okay? There you have it. That's problem number 3. In problem number 4, we have the following problem here. We have 9a squared plus 30ab plus 25b squared. Now notice in this problem we have more than one variable, and the first term is a perfect square. That's right. And the last term is a perfect square as well. So we're once again going to assume that we have a perfect square trinomial and then verify it midway through the process. All right. So I will begin by opening up 2 sets of parentheses here. I'm going to take the square root of the first term, which is 3a. That's right, because 3a times 3a is 9a squared. And then I'll be taking the square root of 25b squared, which is 5b. That's right, 5b. Okay, and then what we want to do from there is determine the sign of those 5b's. And it must be the exact same sign as our middle term here. So that means that the 5b's must be positive. So if I were to multiply 3a and 5b, I would end up with 15ab. All right, just like that. Then multiplying 5b times 3a, I end up with another 15ab. And if you were to combine those 15ab's together, you would end up with 30ab to verify that your original trinomial is a perfect square trinomial. So we'll end up with the quantity of 3a plus 5b squared. And this is the answer. Let's get a red box around this, all right? And here it is. Done, son. That's problem number 4. Another thing I wanted to mention about problem number 4 is check out your variables and their exponents. Make sure that you have a quadratic form when you're doing these problems. As long as your first term's exponent on the variable is twice as much as that variable in the middle term, you have a quadratic form. All right. So for instance, if I focus on a's, my first a is a to the second power. However, the a in the middle term is a to the first power. We'll see that a to the first power, yeah, that 1 is half of 2. So you're good to go. You're also looking for that same effect when it comes to your second variable, this variable b here. Because your last term's variable is raised to the second power, you still want that middle term to represent that variable b with an exponent that's half as much as the last one. So in other words, since I have that last term b raised to the second power, you want to take half of that exponent to end up with b to the first power for the middle term. That ensures that you're dealing with a quadratic expression, which means that you can factor using this process. So let's move ahead. Let's move on. And now we're looking at problem number 5. Okay, so in problem number 5, we have 25 plus 20y plus 4y squared. Now, you can solve this problem the way it is. Yeah, you can, because the first term is a perfect square, the last term is a perfect square, and most likely when you multiply their square roots together, you'll end up with that middle term. But first, let's see, okay? So taking this expression exactly as it is, all right, it'll look like this. We'll go ahead and open up 2 sets of parentheses. Yep. I know that the square root of 25 is 5. That'll be the first term inside the parentheses here. And I also know that the square root of 4y squared is going to be 2y, and that'll go as a second term inside of the parentheses. Because the middle term is positive, my 2y's will be positive as well. And now I can verify that this original trinomial was a perfect square trinomial by multiplying the outer terms together and the inner terms. All right, so let's take a look at what that would look like. If I were to multiply 5 times 2y, I would end up with 10y. If I were to multiply 2y times 5, I would end up with 10y. And if I were to combine 10y and 10y, would I get 20y? Yes, I would get 20y. So that verifies that this is a perfect square trinomial and that I can go ahead and combine these binomials together to get my answer. So I end up with the quantity of 5 plus 2y squared. And this is the answer, just like that. All right, so let's go ahead and put a red box around that. So here we have our answer here, and just like that. Now, I'm going to show you that if you have that exact same problem, so let's look at it again. The 25 plus 20y plus 4y squared, that you could go ahead and rearrange your terms and write it in the standard form of a quadratic expression. In other words, have it in the form of ax squared plus bx plus c. All right. So if I rewrite it that way, then I'll end up with 4y squared plus 20y plus 25. I can still attempt to factor this as a perfect square trinomial by opening up two sets of parentheses. The square root of 4y squared is going to be 2y. The square root of 25 is 5, and because my middle term is positive, the 5's would have to be positive here. Now, due to the commutative property of addition, it doesn't matter whether the 2y or the 5 really goes first. You'll still end up with the same result. However, it is customary to have your expressions written in standard form of a quadratic expression, so that's why this option may appeal to some of you, and which is why I wanted to go ahead and show you this option. We already know that our outer terms and our inner terms are going to match up because the 2y and the 5's will end up making 10y's, and those two 10y terms will add to give you 20y to verify that, once again, this is a perfect square trinomial. So that means that we can simplify this into 2y plus 5 squared as an alternative solution. It's just as good as the one I showed you before, all right? And some may say it's even better because it just looks more familiar to have your term with the variable written first. All right, so let's box it. All right, another way to write your answer for problem number 5. All right, let's start looking at problem number 6. In problem number 6, I have 48m squared plus 75 plus 120m. Now, my first and last terms are not perfect squares. No, they're not. So the first thing I'll do is rewrite this in the standard form of a quadratic expression by writing it as 48m squared plus 120m plus 75. Now, anytime you're asked to factor anything, you're always reading those directions as factor completely, because there may be times where you may be able to factor more than once, depending on the expression. So always read factor as factor completely. The second thing to keep in mind is that you're always going to factor out the GCF first. That's right, the greatest common factor. All right, and if you need a little help with that, check out our video here. I'll put a link right there for the greatest common factor, factoring that out. Factoring the greatest common factor, the GCF. The GCF for this expression is going to be the number 3. That's right. 3 is the common factor, the greatest common factor of all 3 terms here. So factoring out 3, I'll end up with the quantity of 16m squared plus 40m plus 25. All right. Once I have this, note that I have my 3 factored out. However, within the parentheses, I just may have a perfect square trinomial because the first term inside the parentheses is a perfect square, and lo and behold, that 25 is definitely a perfect square, that last term. All right, so this means that you'll be bringing down the GCF, that's 3, and opening up 2 sets of parentheses. All right, we do know that the square root of 16m squared is 4m, so I got 4m as the first term there. I also know that the square root of 25, yeah, it's still 5, and because the middle term is positive, that means that both of those 5's must be positive there. So we still want to verify that that trinomial was a perfect square trinomial. All right, now some of you may be saying to yourselves by this point, Mr. Witt, what would happen if the outer and inner terms don't combine to give me the middle term of that trinomial? What do I do then to factor it? Well, that means that you have 2 possibilities. Either 1 is not factorable, or 2, you need to use the strategy shown in our Factoring Quadratic Trinomials Part 2 video, okay? So definitely check that video out, all right? Got a link down here for you, okay? And it'll also be in the description box as well. So we're going to verify now. So I'm looking at the outer product and the inner product, and 4m times 5 is 20m, whereas 5 times 4m, that gives me 20m as well. And lo and behold, oh, you add that together, you definitely will end up with 40m. So that verifies that 16m squared plus 40m plus 25 was definitely a perfect square trinomial. All right, so now that we can simplify our result here to write our final answer, and it'll be that GCF of 3 times 4m plus 5 squared, and that's the answer. You got it. Okay, let's box it up. Done and done. That was problem number 6. Okay, so let's move on to problem number 7. In problem number 7, we have x to the 4th power plus 8x squared plus 16. Now, this is what I was talking about earlier. As long as your first term's exponent is twice as much as your middle term's exponent, it's quadratic in nature, meaning that we can use the same process in order to factor the trinomial here. All right? So, because the first term's exponent is 4 and the second term's exponent on x is 2, we're good to go. All right? So, that means that the first term's a perfect square, and that 16, yeah, that's a perfect square as well. So what I'll do is I'll open up 2 sets of parentheses here. Okay, the square root of x to the 4th power, all you have to do is take half of the exponent to find the square root. You're going to end up with x squared. All right, because half of 4 is 2, right? Then the square root of 16 is 4. Got my 4 in here. Okay, then because the middle term is positive, that's right, the 4's have to be positive. Done. Now we're going to verify that our original problem was truly indeed a perfect square trinomial by checking the products of the inner and outer terms here. Looking at x squared times 4, you'll have 4x squared. Looking at the inner terms, 4 times x squared is still 4x squared. So if I combine that 4x squared and 4x squared, I do get the 8x squared to verify that the original trinomial was a perfect square trinomial. All right, now that I know that, let's go ahead and write our answer. My answer is going to be the quantity of x squared plus 4 squared. And that's it. That's the answer. Boxing it. All right, just straight boxing it. Ladies and gentlemen, that's your answer for problem number 7. All right, let's move on to the next problem. In problem number 8 here, all right, we have 20p squared plus 100p plus 125. That's right. We already have it written in descending order of our variable, so that means that the variable with the highest exponent is first, and we're working our way on down. Oh yes. And I know that once I have standard form here, that the next thing I need to check for is the GCF. That's right, the greatest common factor. So every last term that you see here in this expression all have 5 in common. So we're going to factor out 5. So, factoring out 5, you have 5 times 4p squared plus 20p plus 25. And notice that our trinomial here appears to be a perfect square trinomial, because our first term inside the parentheses is a perfect square, and here's that 25 again, yeah, and it's a perfect square. So, we're going to go ahead and bring down that GCF of 5 and open up 2 sets of parentheses. The square root of 4p squared is 2p. All right. The square root of 25 is 5. Okay. Because the middle term is positive, that means that both 5's need to be a positive as well. And then we'll check the inner terms product and the outer terms product to verify that our original problem was a perfect square trinomial. So, let's see what happens. We'll have 2p times 5, that's 10p. Then we have 5 times 2p, that's also 10p. And if I were to combine 10p and 10p together, I do get 20p. Yeah, so that means I'm going to simplify my result into the following answer. It's going to be 5 times the quantity of 2p plus 5 squared. And this is my answer, ladies and gentlemen. All right, just like that. In problem number 9, we have x cubed minus 18x squared plus 81x. And what I notice in these 3 terms is that they all have x in common. Yeah, and when you're factoring out your GCF, when it comes to the variables, you'll always factor out the smallest exponent, okay? So that means that my GCF here is x to the 1st power. That's going to leave me with x squared minus 18x plus 81. Checking out the trinomial within the parentheses here, it appears to be a perfect square trinomial. That's right, the first term, x squared, is a perfect square, and 81 is also a perfect square. You'll bring down that GCF of x and open up 2 sets of parentheses. Okay? So the square root of x squared is just x, and the square root of 81 is 9. Because your middle term is negative inside of the parentheses there, both 9's must be negative, like so. Therefore, we'll go ahead and check to see if our original trinomial was a perfect square trinomial. So by checking the product of the inner terms and the outer terms here, x times negative 9 is negative 9x. X times negative 9 is negative 9x. And combining your negative 9x's together, you'll have negative 18x, which is exactly what you have inside the parentheses here. So that verifies that the original trinomial inside the parentheses was a perfect square trinomial, which means we can simplify it. So we'll have x times x minus 9 squared as our answer. And that's it for problem number 9. Let's go ahead and box it up. Gift wrapping for free. All right. There you have it, number 9. Let's check out our last problem for this lesson. Problem number 10. In problem number 10, we have 98 plus 18x squared minus 84x. One thing I notice about this problem is that it's not written in standard form, okay? It's not in descending order of our variable, which is what we want. So let's go ahead and rewrite this first and foremost by rewriting it as 18x squared minus 84x plus 98. Like so. Then we'll be looking for a GCF. Anytime you're factoring, you're going to always understand the directions are factor completely, and you always start by looking for the GCF, the greatest common factor. So from these three terms, our greatest common factor is 2. It's 2. We can factor out a 2. That leaves us with 9x squared minus 42x plus 49. All right? Then what we have left inside the parentheses appears to be a perfect square trinomial, because the first term in that trinomial, 9x squared, is a perfect square, and 49 is a perfect square. So you're going to bring down that 2 and open up 2 sets of parentheses, and then you'll take the square root of 9x squared, which is 3x, by the way. All right, and then the square root of 49 is 7, and because the middle term's coefficient is negative, your 7's, yeah, they must be negative. Now let's verify that that original trinomial was a perfect square trinomial by checking the products of the outer terms and the inner terms here. So 3x times negative 7 is negative 21x, and negative 7 times 3x is also negative 21x, and if I combine those negative 21x's together, yeah, I do end up with negative 42x, all right? And somebody got happy with that 1, so let's go ahead and cut you down a size. All right, there you go. Now, let's go ahead and simplify our result here. You'll end up with the GCF of 2 times 3x minus 7 squared, which is your answer, ladies and gentlemen. Done and done. Let's go ahead and box that up. That's right, boxing up our answers, ladies and gentlemen. So 2 times the quantity of 3x minus 7 squared, that is the result of problem number 10, and that wraps up this lesson on factoring perfect square trinomials. All right, so this is Mr. Witt with Fort Bend Tutoring telling you guys to please rate, comment, and subscribe, and if you're able, please donate, as that helps us bring you more free math tutorials from Fort Bend Tutoring. Peace.
FACTORING. This includes topics such as GCF, that's the greatest common factor, like Obama, the difference of squares, quadratic trichomoniasis, oh Lord, that's when the pig is sick on all 4 sides, the sum of cubes, that sounds like one of them games they play, difference of cubes, oh that's just ignorant. AC method, yes honey, because you got to have your air conditioning in Texas. And factoring by grouping.